Hello, my name is Ramon. I'm studying at the Oslo University and I'm currently attending the network automation course given by Urs Baumann. We had to solve a project on this, we were given a network automation task. We first had to solve in Ansible and now it's the time to solve it with Nornir. We have the task to configure how to provision layer 3 VPN services based on a given services YAML file on this service provider network topology. So we have 2 core routers and 4 edge routers, and the edge routers, they connect to customer resources. In this case, those are just Ubuntu VMs with a static IP address configuration. Edge 01 and Edge 02 are a bit different. They have they're connected to a switch, so they're in a multi-home configuration or dual home configuration. They need to be handled slightly different than what is the case with those. Those are single homed and just connect to one customer per port. And on Edge 01 and Edge 02, this is the distinction is done on VLANs, so each customer is in a different VLAN. The MPLS overlay and the underlay network are already pre-configured, so the core network does not need to be touched at all. We just have to add additional VRFs, configure corresponding interfaces, and set up BGP address family to redistribute the connected routes. Yeah. Okay, so then let's get started. We'll just quickly look at the services file. It is structured like this. It's a YAML file holding a list of customer services which have a name, customer A, that will also be the name of the VRF. We have an ID, we have a description, we have route targets defined, and we have site-specific information. So we see that customer A is present at site A, B, and C, so at all 3 sites. And for each site, we just give the interface configuration. And based on this information, we had to set up now, with Nornir, an automation framework an automation solution to provision and deprovision these services. Here below we have the definition for customer B, and here we just have customer B is at site A and site B compared to site to customer A, which is at present at all 3 sites. Yeah. Currently, the network no layer 3 VPN services are configured. We can verify this by running a ping. So on the right side we have the senders, and on the left side the receivers. The senders are located at site A and the receivers are located at site B or site C respectively. The top row is client A, customer A, and the bottom row is customer B. So nothing configured until now. No layer 3 VPN services. So just turn over to our automation solution to provision the services defined in the services YAML file. So I have this main py file inside the L3 VPN folder, which I called with the --help option, and this shows us the options available. Actually, by default, the automation tool is run in dry run, so we won't do any modifications on the devices, and by default we don't get a verbose output. So I just execute this now with verbose, that we see some output, what's going on, and I just execute it in dry run for now, so it will not change anything. So I press enter. We see a nice progress bar, which is then gonna proceed once the configuration takes place. Cool. So now this looks quite green, so looks quite well. We're just gonna go up and see what did exactly. So we have a root task, configure L3 custom service. This is then carried out on each individual router. In this case, we see Edge 01, and then we have this task is then executed on this router. We gather information, Then we configure the VRFs. For that we get some more information. So we requested the network instances, for example, which shows us that we have only the default and the management VRF currently available. And then we remove obsolete VRFs, so we did nothing on this. But we create missing VRFs, and we see that customer A would be created with these settings here, and also customer B would be added. So that looks quite nice. And then BGP configuration would be adjusted accordingly, and then also the interface configuration would be updated to match like the VRF membership and IP address configuration accordingly. Yeah. Good. So that's done for each individual service, and as we see now, actually that did not help because it still doesn't work, because we run it in dry run. I'm now connected to Edge 01. I'm just gonna do an enable and quickly show the configuration. Here we have the VRF definition of the management VRF and nothing else. So on this device, nothing changed. So what we're gonna do is we're gonna run this script in the mode with no dry run, and still in verbose mode to get some more insight on what's happening. I'm just gonna run it again, and then we'll see what's gonna happen. It's gonna take a few seconds, but will be completed right away. So now that worked, okay. And we have a similar output as before, but now actually the configuration was done because we specified no dry run. And if I gonna take a look at the configuration now, show run, we have customer A and also customer B configured. Accordingly, we have the interfaces, interface membership for the specific VRFs configured, the IP addresses are set, and also the BGP address families are configured as expected. So now actually if I gonna look here, we see we actually run the ping or kept it running. So we see up here there was a destination host unreachable, but now it started working. And same also for customer B. Okay, now it's just gonna remove the service of customer B. I'm gonna remove that one, save the file, and then I'm gonna re-execute the file, this script, and I'm gonna run it one more time in verbose mode. So then we'll see what's being done exactly, and also with no dry run specified, that we have that we get the service removed. Okay, that worked. Everything looks green so far. We're just gonna go to the top and see the results in a better way. So successful 404, fine. And here, like if we look at this more closely right now, we have configure VRF, and that's like gathering facts on about the VRFs, and respectively network instances. That's a synonym. And right now we have before we carried out the removal of customer B service, we had now these two VRFs configured, and the member interface is listed here. Yeah. And if we see here, actually the removal of a service is straightforward. We just remove the corresponding VRF, and the Cisco device handles the deprovisioning of all other settings related to this VRF. And that's being done on all routers. So now if I check here, we have destination host unreachable again for customer B, which is expected because the service has been removed. Now I can remove customer A as well. So I'm just gonna do this, save it, and then we're gonna re-execute, but this time not in verbose mode. We're just gonna do no try run like this. And now, because no services are specified, it will ask me if I really want to do this, because that could be like by mistake we have the wrong file specified or whatever, and we don't want our infrastructure to be like deprovisioned. Yeah, that would be like network automation in the sense of fuck up at scale. We don't want to do this, so it will ask us to confirm, and in this case I want it, so I do yes, and it will remove custom await service. So now all services will be deprovisioned again. Yeah. All right. So now we have like just no verbose outputs, just the state. So it is green. So we configured on H01, on H02, and H03 and H04. We successfully configured L3 custom services. So those tasks were executed successfully. All right. Good. Just to confirm quickly, no more packets can be sent for customer A and also not for customer B. Cool. Now quickly, how is that being done with Nornir? Just gonna first look into the configuration. We use as an inventory, we use the simple inventory, and we define a host file and group file and defaults file, which we're gonna look at in a second. And then we have a runner specified, which is the threaded runner, and it is like we execute 4 workers at the same time, so we can actually, because we have 4 edge routers, we can configure them in parallel. Okay, now the inventory, so we have a defaults file specifying the path to the service file, the BGP autonomous system number of the ISP network, then the system VRFs, which should not be touched by automation, and the primary loopback interface, which is used to establish BGP peerings between edge routers. Okay. Then we have the groups defined. We have Cisco group, which defines connection-specific parameters, and we have a group for each site, which defines, which just holds one boolean in the data section, whether the site is multi-homed or not. Now our hosts, we have like H01, H02, H03, and H04, like these 4 edge routers defined. They have each of those have a host name, and they're a member of 2 groups. One is the Cisco group, and one is the site-specific group they're in. And then we specify some optional data, in this case HSRP configuration for multi-home sites, virtual IP offset, and the priority. Same for H02 and H03 and H04. They don't have any optional data specified because they're single-homed and they don't need these multi-homed configuration parameters. Okay, now just a few more minutes on the Python script. So we start at the main Py. We have like these Nornir modules imported here, and we can execute the main function using typer, which gives us some nice handling with the options. So it's a very nice tool to make the command line utility more intuitive. We specify the options. This will be read by typer. We have dry run, which is by default true. We have verbose, also boolean, which is by default false. And then we set up our Nornir object. We read the configuration. We're gonna initialize the global, like the data, which is static for each service, like the same for independently from on which side it is configured on, is stored in this dictionary. We could just get this information using a helper function, and yeah, in case the service definition is empty, so that's the case when we remove all services, it will just confirm or ask for confirmation if we really want to do this. Then we're gonna use rich as a progress bar, some nice output. It looks fancy, and then we have then we run the Nornir task with this progress bar, and we just execute the configure L3 customer service task, which will return a result object, which will then be printed by Nornir rich with the log level specified as command line argument. By default, it is logging error. And now let's look at this task. We have this configure L3 customer service task, which is actually the root task of all the, like it executes some subtasks, and which first get the name of the site the host is located in. We initialize some site-specific information for that specific host, and which we'll need in a later step to configure the VRFs, configure BGP address family, and do all that kind of stuff. And then we execute these 3 subtasks in sequence, which is the configure VRF task, configure BGP address family, and configure interfaces. Those are defined in the tasks folder. For VRF, we have this configure VRF task, which basically determines the VRFs which are obsolete, so which will need to be removed, and with the missing VRFs would need to be added. So 2 new subtasks are executed in sequence, which actually removes the obsolete VRFs and here creates those VRFs which are missing. And these 2 tasks are defined here, and we use, or napalm configure is used to do this. We just give it a commands string, which is crafted in this case with a list comprehension, but below here we use a template VRF config J2, which is stored in templates folder right away here using Jinja templating. I'll not go into details on this, but the code will be available, so you can take a look at this. And now the main file, the next would be BGP address configuration. That's similar to the VRF one, just simpler. We have just one task which runs here, uses also napalm configure based on a Jinja template. And the interface configuration is a bit more complicated because we need to distinguish between multi-homed and single-home devices, so we have a different task on that. But basically it's the same again. We just have a Jinja template which is used to craft the commands, and then we use napalm configure to apply that based on the information we have for site-specific and host-specific, like global settings stored in the task file. Like based on that information we actually retrieved from the services file. Yes, that's it. Here, like maybe the last task to mention is this one, delete unused subinterfaces. This one is going to remove the subinterfaces which are not required anymore. So for example, if I connect on the router, we have now no more services configured. So if I do a show IP interface brief, we see that actually the subinterfaces here are in deleted state. So when I would reload this router, those would disappear afterwards. So it also cleans up those subinterfaces, which is quite nice. All right, that was the Nornir demonstration of my solution about this task given as part of the network automation model. I hope you enjoyed it, and yeah, enjoy automating.